Question 10, we're dealing with an optimization problem, and we have here that a head box in the shape of a circular cylinder is to be constructed in such a manner that the sum of its height and the radius is 9 units. Determine the radius for which the cylinder has the largest possible volume. So we have this constriction that the height plus the radius should give us 9. And from this, we can just make h substitute the formula and say h will be equal to 9 minus r. Then, since we're trying to optimize for the largest possible volume, we know that the volume for a circular cylinder is pi r squared h. Also, you can see it given here. We have to determine the radius for which the cylinder has the largest possible volume. So we're going to try and write this volume formula in terms of just radius. So we want to express volume in terms of radius. So this is in terms of radius. This will be equal to pi r squared, but then h we're going to now replace with 9 minus r. And from this we can multiply in. This will give us 9 pi r squared minus pi r cubed. Then, since now we have a formula that is based on the radius alone, we can get the first derivative. So if we get the first derivative of this function and equate it to 0, we'll get the radius that allows for the maximum volume. Therefore, it would look something like this. So it would be 18 pi r minus pi minus 3 pi r squared. So multiply by the power, then subtract 1 from the power, and we want to equate that to 0. And then from this, we can simply factor out 3 pi r from each part. So 3 pi r from this would be 6, and then from this it would be minus r is equals to 0. Then from this we can say that r is either 0 or r is equal to, or let me just write it as 6 minus r is equals to 0, where r is either equal to 6. So this is the only one that makes sense. Since our radius cannot be 0, it can be a positive number, which is 6 units, and that would be our answer.